Hi everyone, welcome to Educon Community Java Crash Course. So today we will discuss about the platform independence in Java. So platform independence means that a Java program can run on any operating systems like Windows, Linux, Mac OS without modification. So this is achieved by compiling the Java code into an intermediate form which is called as the bytecode and which can then be executed on any platform that has a Java virtual machine, right? So that JVM file extensions are different in different operating systems. Like in Windows, it is .exe, and in Linux, it is .out, and Mac, it's .dmg. Okay, those extensions are there. So that's why that Java virtual machine is platform dependent. But that bytecode is platform independent because that can be executed in any operating system, right? So that's why this is platform independent. Okay, now we are going to break it. So first of all, compilation process in Java. So when you write the Java code, it goes through the multiple phases. The first one is your Java source code, which extension file is .java. That's written by the developer or programmer, and then the Java compiler. So through that Java C, then your Java extension, like with the extension file, you will write the comment. Suppose you have written the hello world.java. Okay. So for compilation, you will do like Java C space hello world.java. Then it will basically converts the source code into the bytecode. Means from that .java extension file, you will get the .class files, and inside that .class file, your bytecode is there. And after getting the Java bytecode, means the .class extension file, this Java bytecode is basically the platform independent, which is platform independent intermediate code. And next, the Java virtual machine. So after getting the Java bytecode, there is one concept which is class loader. So that class loader, okay, load your .class file to the JVM from the GRE, and it basically interprets and executes the bytecode on the specific operating system. Then the detailed flow is like write the Java code, which I have told you, which is hello world.java, which created the Java code, then compile code, it creates the hello world.class, then bytecode generation, the compiler generates the bytecode, not the machine code in .class file, then JVM execution. So the JVM translates the bytecode into machine code during the runtime on any operating system. And inside that, here from that bytecode to machine code, JIT compiler is there. JIT compiler. JIT means just in time. So JIT compiler will transfer to the machine code from the bytecode, and this will happen in the runtime. So if you will consider in this like your source code, source code, and then it will go into the like Java compiler, and Java compiler will transfer like process it, and will uh, this source code will become the bytecode. Okay, so here this source code means your dot Java file, right? And this compiler is basically your Java C, right? And next, this bytecode means your dot class file, Got it? So these will be happened in the compile time. In the compile time. And next, what will be done through the JIT? Next is will be your JIT compiler. Okay, this JIT compiler is a part of basically the JRE or the JVM, you can say. Okay, like this is the part of mainly JRE, JIT compiler just in time. So this JIT compiler will convert this bytecode into the machine specific code or machine code, right? So this process will be happened in the runtime. Okay, so this is the main concept. Okay, so this bytecode is platform independent, but this JVM will be platform dependent. Okay, so like illustration here also it's mentioned that this Java source code dot Java, then Java compiler, then Java bytecode, then JVM platform specific Java virtual machine like Windows JVM, Linux JVM, and Mac JVM, and it executes bytecode on any operating system. Now, why is bytecode platform independent? The bytecode is a set of instructions that are understood by JVM, not by the operating system. And every platform has its own JVM implementation, but the bytecode remains the same. Okay, so basically, this bytecode is a source of set of instructions, and it will be understood by JVM only, not by the operating system. And this JVM is operating system specific. Okay, and every platform has its own JVM implementation, but the bytecode will be same. Like JVM on Windows, Linux, or Mac OS translates this bytecode into machine-specific code during the runtime. What I have told here in the runtime, this bytecode into the machine code through the JIT compiler, and here it is JavaC compiler. Okay. Next is like I have written suppose the hello world.java file, and this is the main method, and inside that this is the println, and here I am printing that hello platform independent Java. So after compiling means here you will do java c, then hello world.java. You will do here this. Yeah, here also it's mentioned. So not to mention here. So after compiling means java c hello world.java, and output will become um, hello platform independent Java. Okay, but after that one more process is there. So Java hello world. This you need to do. Okay, or you can also like this is the two process. Okay, this compilation and then execution, two process. This two process will become one process if you will do that Java hello world dot Java. If you will do that, then you need not to do these two process. You will like through this one comment, the compilation and execution will be done, but that is not recommended. Okay, don't do this in your industry or any organizations. Okay, the people will say that you don't know anything because that's the main process. Okay, they will understand that you have mistaken and you have written this, right? So it will be printed. So this dot class file can be executed on any system with a JVM regardless of operating system. So the compiler Java C doesn't generate machine code directly. So it generates an intermediate form, which I have told here. This bytecode will be generated and through the JIT compiler. Okay. So which can run on any machine with a JVM, and JVM acts as a interpreter or just-in-time compiler and this JIT compiler translating the bytecode to the machine code during the runtime. Now JVM versus JRE and JDK. Java development and runtime environments are built on top of three keys components. First one is JVM, which is Java Virtual Machine. It basically executes the compiled bytecode and it is platform specific. Like for Windows, it is like .exe file. For Linux, it will be like .out extension file. And for Mac, that is basically uh, .dmg extension file. Okay, and then JRE, which is Java runtime environment, and it basically contains the JVM and the libraries needed to run the Java program. As if you will write some code, then only that code is not uh, proper for running your whole applications, right? There will require more external libraries and all. So those external libraries and all will be also there in the JRE. And JDK means JDK is the most outer part. So it consists of JRE and tools like compiler, Java C, then debugger, and some interpreter. Those things are also there. Some archive files also there, like dot jar file, dot jar file. Those are also there. Okay, so for more development and like that. Then what is the JVM? Like the main concept. What is the JVM? So basically, JVM is the core of the Java platform, and it provides an environment for executing your bytecode and making Java platform independent. And every OS has its own JVM implementation. What I have told here. Okay. Now key responsibilities of JVM. So there is a class loader which loads the dot class files into memory, and then bytecode verifier. It basically checks the illegal code that violates access rights. And next is execution engine, executes the bytecode through interpreter and JIT compiler. So interpreter executes the bytecode line by line, and JIT compiler means just in time that compiles the bytecode into the machine code for better performance. Okay. So inside that JVM, main three parts are there. First one is class loader that basically loads your class files into the memory. Next is your bytecode verifier that basically checks the illegal code that violates access rights. And next is your execution engine, right? So that basically executes your bytecode through your interpreter and JIT compiler. Got it? Next is JVM memory areas. So first one is the method area, which basically stores the class structure and method data. Next is your heap, which basically stores the objects and instance variables. And next is stack, and stack stores the method calls and the local variables. So main difference between heap and stack is like that. Heap will store your objects and the instance variables only, but stack will store your method calls and local variables, right? Next is your PC registrar. So it basically stores the address of the current instructions. And next is native method stack, that basically for native methods in the application. Next is your Java runtime environment, which is a collection of libraries and the JVM that allows running Java programs, which contains like JVM, some core libraries like java.lang, java.util, and runtime libraries and utilities are there. Got it? Next is your JDK, and JDK is a complete toolkit for developing the Java application. So inside the JDK, there JRE is there, compiler is there, debugger is there, tools like Javadoc is there, jar is there. Jar means the some Java archive files are there. Javadoc means for documentation purpose in Java. So all those things are inside the JDK. So JDK consists of JRE and other tools like compiler, debugger, Javadoc, jar. Those things are there, right? So again, the difference between these JVM, JRE, JDK. So for purpose, so the purpose of JVM is executing the bytecode. JRE basically provides the environment to run your Java file. Next is JDK. JDK means your provides the environment to develop the Java. Okay, GRE means GRE basically provides the environment to run the Java file, and JDK provides the environment for development of Java. Then contains JVM engine only. GRE, some JVM and external libraries are there, and JDK. This is JRE, some compiler and other tools like Javadoc, jar. Those things are there inside the JDK. So tools inside JVM, no other tools are there. JRE basic libraries are there, and JDK like compiler, debugger, profiler tools are there. So JVM is for running your programs. JRE also is like running the programs, and JDK means the name like the Java Development Kit. So this name suggests that it developing and running the programs. Got it? So next is like code example. So you have written suppose hello world.java, then compiling using Java C hello world.java and run using JRE. So this Java hello world, okay, means executing. So JDK basically compiles the code. Okay. Then JRE provides the runtime libraries, and JVM executes the compiled code. And through the JVM, your bytecode will be translated into the machine code. Okay. So JDK compiles your source code. JRE provides the runtime libraries and provides the environment, and JVM executes that code. Okay. So then Java program, Java compiler from JDK, then Java bytecode, then JRE with the JVM, then your machine code. Here you can say the JIT compiler plus interpreter. I have told you, right? Here again I am showing you that JVM consists of class loader, bytecode verifier, and execution engine. For execution engine, it's like interpreter and JIT compiler are there. Okay. So class loader basically loads your .class files into memory. Bytecode verifier checks the illegal code that violates access rights. And execution engine like execute bytecode through interpreter and JIT compiler. So interpreter executes your bytecode line by line, and JIT compiler compiles the bytecode into machine code for better performance. Right? Okay. So conclusion like so platform independence is achieved through the bytecode JVM model, and JVM is responsible for uh, executing the bytecode and ensuring the same code runs on different platforms like different operating system. And JRE is essential for running your programs, while JDK is for developing and compilations. So that's all. Next, I will discuss about the strings related things, right? So till then, stay tuned and do like, share, and subscribe the channel for getting more discussions, more topics will be covered here. Okay, thank you.